Hello, this is Tyler Slater, and this is Phase 2, Part 2 homework assignment submission for EGR 425. Real quick, I do have M5 core 2 processor hooked up to VCNL 4040 right there. So it is hooked up to the computer. What this app does, app 3, it basically asks the VCNL 4040 for specific information by sending a request to a specific spot in the sensor's memory, and then it calls back and it not only it sends it but also receives the sensor's information from that particular spot in the memory. So we were also able to do a port scan to find out the VCNL 4040 address, which is 0x60, which if we look at the documentation, it is also correct. So we're going to upload this real quick, making sure it's building correctly. So usually this takes around 15-20 seconds. Yeah, perfect, it's already going. So we'll wait for that. That is a success, and now we're going to open up the serial monitor, and we are looking for the status, which everything is correct. So it does say I2C read at address 0x0C is 0x0186 and an expected device ID of 0x0186. So that is correct. That is working correctly. I'll see you in app 4. Alright, here is app 4 for phase 2 part 2. What's different about this app is instead of just reading, we are now writing to the sensor as well. So how we do that is through these custom functions right here. What this code does is first it checks to make sure that we are talking to the VCNL 4040. It checks to make sure it's the correct sensor, and then it reads the data from a specific spot of memory in the sensor. Then it writes to a specific spot from the sensor, and then after it writes it, we're going to be reading it again, which we'll see when we actually run the code. But yeah, these are the two custom functions for writing, and then this one writes new values and this one reads the new values that have been written. So we are going to upload the code right here. Here it looks like it's working correctly. And we will wait for this to build now. Once it is built, we'll be able to also hit the serial monitor. What we're looking for is there you go, now it's going. We're looking for it to read what we already wrote, which is right here. So this is what we're writing onto the sensor, 0x1234. So it is a success. We are looking for this, so when we do hit the serial monitor, boom. So we do have the correct status that we want. It is reading 0x0186, and then it's reading the newly written 0x1234, which is exactly what we want as we have it right there. Awesome. So now I'll see you in app 5. So now we are on to app 5. This kind of merges what we learned in app 3 and app 4 together. It does both at the same time. We also included a custom library that we have in the include file up here. This basically just simplifies the code and makes it easier to maintain, and for readability's sake, for the code that we have in our source file down here. I enabled these to true. We'll start running right now. This is just a good check to see if our code is working. We actually don't need these to be true. We're going to run it once with them at true, and then after it successfully compiles, I'll show you it while it's at false. Well, all three of them are set at false, but I'll show you this real quick. That's success, and I'll do the serial monitor, which you can see is working correctly. So you have the statuses in between the proximity, ambient light, white light, and you can see also that the VCNL 4040 is working. If I just hold it, you can see the proximity is going up in value. And then I'm going to end the serial monitor and quickly change these all to false, which doesn't really need to be shown, but I'll show you anyways, just that this is working correctly, and then we're going to run it again. Basically, what I learned in this code, not only does it initialize the data, but it also reads the data from the specific memory spot in the sensor, and then it processes the data and displays the results. So I'll run it one more time, and it should build, and basically the same thing should show up except for the status. The status print statement shouldn't be there anymore. It will just be the proximity, ambient light, and white light data. So that built, so we will run the serial monitor, and you can see that it is working correctly. Awesome. Thanks for watching.